Hello everyone. This video is in continuation with the previous video on the same chapter, Matter in Our Surroundings. If you haven't seen that video, then please do check it out. If you haven't seen that video, then please do check it out and subscribe to our channel. In our previous video, we discussed in detail what is gaseous state and differentiated all three states based on their property. Today we will discuss whether matter can change its state. We all know that water can exist in three states of matter: solid, as in case of ice; liquid, as the familiar water; and gas, as the water vapor. Now the question arises, what happens inside the matter during this change of state? What happens to the particles of matter during the change of state? And how does this change of state takes place? We shall be discussing all these questions as we move forward with today's topic. Moving on, effect of change of temperature on the states of matter. Let us consider an activity. Here we have taken 150 gram of ice in a beaker and suspended a laboratory thermometer so that its bulb is in contact with the ice. Here we have two apparatuses. In the first apparatus, we can see that a beaker contains ice and is placed above a stand beneath which we have a burner. Also, we have added a thermometer whose bulb is in contact with the ice and a glass stirrer. We start to heat the burner and slowly ice starts to melt. Similarly, in the second apparatus, we have a similar arrangement with the change that we have water inside the beaker instead of ice. Again, thermometer is in contact with the water so that we can note the temperature changes simultaneously. From the first apparatus, we see that as soon as ice reaches a certain temperature, it starts to melt and is converted into water. Similarly, in the second apparatus, we see that as soon as water reaches a certain temperature, it turns into the gaseous form. We would now be discussing what exactly happens inside the particles which causes the conversion of state of matter. From the first apparatus, we see that as soon as ice reaches a certain temperature, it starts to melt and is converted into water. Similarly, in the second apparatus, we see that as soon as water reaches a certain temperature, it turns into the gaseous form. We would now be discussing what exactly happens inside the particles which causes the conversion of state of matter. On increasing the temperature of solids, the kinetic energy of the particles increases. Due to increase in kinetic energy, particles start vibrating with greater speeds. We know that in case of solids, particles are tightly packed. As soon as the temperature of the solid increases, particles within the solid tend to vibrate with a greater speed. The energy supplied by the heat overcomes the forces of attraction between particles. Particles start to leave their positions and move freely. A stage is reached when solid melts and is converted to liquids. Considering the example here, as soon as heat is provided to the beaker containing the ice cubes, the kinetic energy of the particles of the ice increases, as a result of which particles start to vibrate with a greater speed. The beaker is continuously provided with the heat, and this energy is used up to overcome the forces of attraction between the particles. As more and more heat is provided, particles become more and more free, and eventually they change their state to liquid state. The temperature at which solid melts to become liquid at atmospheric pressure is called the melting point. The temperature at which ice cubes become liquids is called the melting point of ice cubes. The melting point of a solid is an indication of the strength of forces of attraction between its particles. Melting point basically tells us the temperature at which a solid changes its state to a liquid. The melting point of ice is 273.16 Kelvin, which is also written as 273 Kelvin for better calculation, equals to 0 degree. The process of melting, that is, change of solid into liquid, is also known as fusion. Now, when a solid melts, its temperature remains the same. So where does the heat energy go? In the activity conducted, the temperature of the system does not change after the melting point is reached, till all the ice melts. This happens even though we continue to heat the beaker. According to our observations, the temperature remains constant throughout the process even when we are continuously supplying heat to the system. Then where does all this heat go? The heat gets used up in changing the state by overcoming forces of attraction between the particles, as a result of which the temperature of the system does not change after the melting point is reached till all the ice melts. As the heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. Latent means hidden. Now, we need to note down a very important definition. The amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Therefore, particles in water at 0 degree have more energy as compared to particles in ice at the same temperature. Moving on to the conversion from liquid to gas. The process is similar, just in this case we undergo the process of conversion from liquid to gases. When we supply heat energy, water particles start moving even faster. As the temperature rises, the kinetic energies of the particle keep on increasing, as a result of which at certain point particles attain energy to break free from the forces of attraction, as a result of which liquid starts to change into gaseous state. The temperature at which liquid starts boiling at atmospheric pressure is known as boiling point. This conversion is a bulk phenomenon because particles from bulk of liquid gain enough energy to change into vapor state. For water, this temperature is 373 Kelvin, which is 100 degrees Celsius. Here we can see that the melting point of ice was 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. The particles in steam, that is water vapor at 100 degrees Celsius, have more energy than water at the same temperature because particles in steam have absorbed extra energy. This extra energy is the latent heat. Here we have a small representation which clearly specifies the conversion of solid state into liquid by heating and liquid to gaseous again by heating. To reach back to the solid state again, if we cool down the water vapor, we obtain the liquid, and on further cooling we obtain ice cubes, which are the initial solid form. That's it for today's lecture. In today's lecture, we studied about the effect of temperature on the particles of matter, how providing extra heat increases the kinetic energy of the particles, as a result of which they overcome forces of attraction and change their state. We also learned about latent heat of fusion, which is the amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point. We also discussed how particles in water at 0 degrees Celsius have more energy as compared to particles in ice at the same temperature. That is it for today's video. If you liked this video, then please give a thumbs up and subscribe to our channel. Thank you.